Hi, my name is Beecks, and I'm happy to present you our paper about the knowlEdge project. In this talk, I would like to give you some insights into this project. I would like to show the overall concept and innovations, and I would like to actually present you why artificial intelligence is important for Industry 4.0. It is important for agile manufacturing. This paper is a joint work with the knowlEdge consortium partners. And before I introduce the project, I would like to start with a small introduction. We all know that artificial intelligence is one of the biggest megatrends in the fourth industrial revolution. AI provides a rich stack of methods and techniques that can be used to improve production. We also know that there is a demand for smart and agile manufacturing solutions. And together with that, we can observe that there is a continuous growth of data in the manufacturing domain. This data is coming from processes, machines, control systems, sensors, and other IoT devices. Now we have the knowlEdge project, which aims to address the need for new AI solutions. And we particularly look at solutions that are agile, reusable, distributed, scalable, accountable, secure, standardized, and collaborative. So let me start with a quick introduction to that project. The knowlEdge means, or the complete title of this project is Towards AI-Powered Manufacturing Services, Processes, and Products in an Edge-to-Cloud Knowledge Continuum for Humans in the Loop. It is a project belonging to the ICT 38 core and has started at January 21 with a duration of 36 months. As you can see on this map, we have partners across Europe. I don't want to go into detail here. Let me go one step back to the background because nowadays everyone wants to be competitive. This holds particularly true for the manufacturing domain, where manufacturers seek new ways that ensure dynamic responses to changes that can happen in the technologies, that can happen with the materials, but also to the customer preferences. And so, to make use of the potential of the digitalization and the progress in the technology, they have to combine smart and connected technologies. And accordingly, companies must address the transition with digital technologies and to reinvent their products, processes, and services from a variety of perspectives. This means that there is a convergence of technologies, such as artificial intelligence, data analytics, Internet of Things, and so on, that have to be taken into account in order to move forward, in order to become more competitive. And this leads us to agile manufacturing, which is basically the main goal of the knowlEdge project. On this slide, I've summarized the overall concept. You can see that in this picture on the left-hand side, where you see the current status of traditional manufacturing, and where you see our vision, where we aim for the agile manufacturing. And as you can see in this figure, the knowlEdge project aims to first advance from traditional manufacturing processes to more agile processes, which are able to timely adapt to changing market needs. The second thing is that we aim to enable quality inspection, prediction, and control across all stages of production. The third thing is that we aim to provide dynamic process optimization in real time. And the fourth thing is that the project aims to closely couple the collaboration between humans and AI in order to exchange knowledge and train employees. And fifth is, of course, to make the whole system more intelligent, to enhance data analysis within the compute continuum, meaning that we put the analysis between edge, fog, and cloud. And to achieve this, we have several technical elements that are depicted in the middle of this figure. We have this knowlEdge discovery service, which provides state-of-the-art data mining and machine learning services, right? We have the distributed AI models, which should be explainable, which should be adaptive, and which should incorporate the latest trends. And then we have the digital twin in order to do some kind of simulation. I think that is needed everywhere. And then we have the two-axis decision support framework or human control in order to achieve this element of the agile factory. So what I want to say is that with this project, we aim to converge techniques from different computing areas into a unified software architecture, which can then be used to automatically extract and utilize the data. And moreover, this architecture will also provide a way of reusing and sharing AI models in a semi-automated way. That means that the companies can decouple or independently develop and deploy their models because the software architecture allows us to share these AI, this knowledge across the companies. What are the objectives of the project? So we have 8 objectives identified so far. The first objective is from the knowledge discovery and management domain, where we aim to develop an AI-centric software architecture to support agile manufacturing processes by capturing and processing data from heterogeneous sources. I mean, this is necessary because we cannot accept only sensor values. We also have complex unstructured data, images, videos, maybe also audio files. The second objective is from the software engineering and AI domain, where we aim to simplify the development, the integration, and uptake of smart and frugal AI techniques that can work with the available data are down to small batch sizes or lot size 1 production processes. The third objective is from the distributed and parallel computing domain, where we aim to develop a deployment model capable of distributed data mining and analytic services across the compute continuum. Right? This means that we can scale these models to edge, fog, and cloud continuum. The fourth objective is from the digital and multi-sided platform domain, where we aim to develop an interactive and multi-sided knowledge marketplace that allows us to share the AI models, that allows us to share the knowledge within a factory and also across multiple factories. Here are the objectives 5 to 8. The fifth is from the data management and governance domain, where we aim to provide efficient and secure communication, data management, and governance infrastructure. Right? I mean, this is clear in order to support the development of collaborative AI applications that work with humans and data across various sources. The sixth objective is from the human-centered design and human-computer interaction domain, where we aim to develop advanced user-facing applications and services. So basically, put the human into the loop, put the human to the AI system. The seventh objective is from the application and product quality domain, because we also aim to demonstrate and evaluate the knowledge framework to build a proof of concept use case that we can show how it works and that other people can benefit from this demonstration. And this leads me to the 8th objective from the outreach domain. Of course, we want to disseminate the project outcomes. We want to communicate them, provide guidelines, provide lessons learned, provide best practices so that everyone can benefit from the outcomes of this project. Let me say something about the applications, more precisely about the use cases and the objectives. In this project, we have initially four use cases that are depicted here on this slide. The first use case is about continuous tracking of processes and intelligent scheduling of production, where the objective is to increase the information collected in order to create an optimal schedule plan and adjust this plan in real time. So basically, use the information that is available, use all information that is available, and try to analyze this information in real time in the cloud continuum in order to optimize the schedule plan. The second use case is about fault detection and prediction for increased production quality and process efficiency, where we aim to make better use of available data in order to ensure that the supply and production scheduling processes are more efficient. And in addition to that, that human activities are clearly defined in line with automated solutions. So basically, that a human has a chance to meaningfully interact with the system. The third use case is about production optimization for small batches, where we aim to increase the efficiency, to improve product quality, and to do so, we aim to use the digital twin in order to reflect and simulate and predict the behavior of the system. And the fourth and final use case is about AI video analysis assembly supervisor, where we monitor the assembly process, and we do this by making use of video records, analyze video segments that can then help us to improve this process. All right, that's basically all I wanted to say. Thank you very much for listening. If you're interested in this project, please have a look at this website where you can find more information about this project, more information about the partners and the latest news. Otherwise, you can also send us or you can send me an email if you have more questions. Thank you very much. Bye-bye.